Another type of security model is called the access control matrix model. The access control matrix model is used primarily in discretionary access control models. This is what we use on most of our commercial networks using Microsoft Windows operating system, or perhaps Unix or Linux, or even the Macintosh. They all principally use the access control matrix model. Now, this is where we have a subject who gets identified and gets assigned an access token. Objects have something called the ACL, or access control list. This access control list that is bound to the object contains a list of all the subjects and their level of access. That's what the ACL contains. So we're going to now look at a diagram that helps us further describe this. This diagram shows us the access control matrix. And as we look, we see in the very first column, we see a list of subjects. And that first column is subjects. Second column is an object called file1. Further, the privileges granted to the subjects for file1 in the column are referred to as the access control list for file1. So the access control list is bound to the object. And if we look at a row in this table, we see that a subject's row is the subject's capability. So the row is the capability, and capability is bound to the subject, while the column is the object's access control list. The ACL is bound to the object. Again, this is used primarily in discretionary access control models, which is principally what we use on Microsoft networks, Unix and Linux networks, etc. Another model we're going to look at now is called the Brewer-Nash model. This model is also referred to as the Chinese wall. This model was implemented to ensure fair competition and eliminate the possibility for conflict of interest. What this model is based on is context, not content. So if you see any questions related to access controls based on context, the Brewer-Nash model or the Chinese wall model is a model that builds its rules based on context. And here's the context we're talking about. Again, this was designed to avoid a conflict of interest. So the rule says that if a subject has not accessed any company's data, he's allowed to access any company's data. But as soon as he accesses one company's data, the Brewer-Nash model builds a Chinese wall. It dynamically implements ACLs, or an access control list, that says the subject is now only allowed to access that first company's data and is not allowed to access any other company's data. So until he commits on one of the company's set of data, he can access any of them. But once he accesses any one company's data, the Chinese wall pops up dynamically and says, you can only now look at that company's data and you cannot look at any other company's data. And again, this was designed for a commercial model to avoid conflict of interest concerns. So again, this was a way of separating competitors' data within the same integrated databases, such as on the stock market or something along those lines. And again, the things to remember here is it is context-based. It's to avoid conflicts of interest. It's a commercial model. And it dynamically assembles ACLs to disallow a subject to access other companies' information. Another model we need to know something about is called the take-grant. This may also be called the grant-take. Now, those aren't two people. This is a model that identifies a framework for granting and then removing or revoking those access permissions. So again, this is implemented not to provide a certain access or deny a certain access, but it's the mechanisms to grant or revoke those access privileges. This model is also used in the testing of other access control models to ensure that if I grant these three permissions, do I really get just those, or does it somehow allow me to get other accesses? So again, this is another formal mathematical model, academic model designed to teach us, to give us rules on how we should be granting and revoking privileges for users accessing of objects. Another rule or model is called the Graham-Denning model. Now this model is designed to help us manage subjects and objects and the granting or management of access privileges. So that's principally what Graham-Denning model deals with, is the management of subjects, the management of objects, and the management of granting or managing access privileges.